For this lesson, we are going to be going through how to solve quadratic equations. So to start, let's do a quick review of the properties of quadratic functions. So to start, a quadratic function is distinguishable by the fact that its second differences are constant. So if I go through and calculate all of my second differences, they are all the same. Next, a quadratic function has a degree of 2, so it has an x squared in it, and that is the highest exponent that's there. And finally, a quadratic function can be expressed in 3 different algebraic forms: standard form, factored form, and vertex form. So now let's look at the graph of our quadratic function. So a quadratic function forms a parabola on a graph. And there are a few key points on a parabola that we're going to review. So to start is our direction of opening. So if I look, my parabola is opening upwards. Next is my vertex, and my vertex is the turnaround point on my parabola. So in this case, it is at 1, -9. Next is my axis of symmetry. So my axis of symmetry is the line that splits my parabola in half. In other words, if I folded my parabola over this line, it would be symmetrical on both sides. So the equation of the pink line is x equals 1. Next are my x-intercepts, So my x-intercepts are where my graph crosses the x-axis. So there's one here and one here. And sometimes you will hear your x-intercepts referred to as zeros. That means the exact same thing. So my x-intercepts are zeros are at -2, 0, and at 4, 0. Next is my y-intercept, so where my graph crosses the y-axis. So I look down the y-axis and it crosses right here, and that is at 0, -8. Next is my minimum or maximum value. So in this case, my parabola gets lower and lower and lower until it hits -9, and then it turns around and increases. So that means I have a minimum value of -9. Next is my domain. So there's nothing stopping my x values from continuing on. There's no turnaround points, there's no asymptotes, nothing like that. So my domain is just x is an element of real numbers. Next is my range. So if I look, all of my y's are above -9. It goes down to -9 and turns back around. So my range is y is an element of real numbers such that y is bigger than or equal to 9. So that's our quick little review of our quadratic function. Now let's go over how to solve these things. So there are a few ways to solve our quadratic functions. The first option is to graph and locate the x-intercepts or zeros. Next is to factor and setting each factor equal to 0 to find our roots. And finally is to use my quadratic formula to find the roots. So here is the breakdown of the terminology. So x-intercepts are on the graph. So where our graph crosses the x-axis, those are x-intercepts. Next are my zeros. So functions have zeros. So if I'm looking at the x-intercepts of a function, those would be my zeros. Finally, my roots are from an equation. So if I have an equation, that would be roots. So let's do a little bit of a review. This was covered in grade 10, so this should be stuff we're all familiar with. So the first one here, determine the roots of each equation by factoring. So for this first one, we're going to start by factoring our function. So here I can factor out a 2x, and I'm left with x minus 7. Now what I do is I'm going to set the whole thing equal to 0, and then I set both of my brackets equal to 0. So I set this equal to 0, and I set this equal to 0. And now I solve for x. So I divide by 2, I'll get x equals 0. And on the other side, I get x equals positive 7. So that means that my roots are x equals 0 and x equals 7. So that's our first example. Let's do another one. So for the next one, we're going to start by factoring. So I need two numbers that add to 2 and multiply to negative 3. So that will be x plus 3, x minus 1 equals 0. And now I'm just going to set both of my brackets equal to 0. And that will give me that x equals negative 3 and x equals 1. So there are my final answers. For our next example, we have 2x squared equals 5x plus 12. So the first thing we need to do is we need to make this equal to 0. So all of this stuff only works if this is equal to 0. Next, let's go through and factor. So the first thing I do is I common factor out what I can. So I can common factor out that negative 1 to start. There we go. And now I'm going to factor this. So I need two numbers that add to negative 5 and two numbers that multiply to negative 24, like this. And that will give me 8 and 3, so I'll have negative 8 and 3, 8 and 3. And now instead of writing in negative 5, we'll have negative 2x squared minus 8x plus 3x minus 12. And now we're just going to factor by grouping. There we go. And now we have x minus 4 to x plus 3. And now we can just set those brackets equal to 0 again. So we don't need to worry about that negative because it will end up equaling 0 no matter what. There we go. So now let's solve for x. We have x equals 4 and 2x equals negative 3. So there are our answers. All right, next one over here. Same idea, we need to make sure that this is equal to 0 first. So we have x squared minus 10x plus 25 is equal to 0. And now we need to factor. So two numbers that add to negative 10 and multiply to 25. So we'll have negative 5 and negative 5. So we'll have x minus 5 equals 0. So we get x equals 5. So if we get it twice, it just means that x equals 5. There's only one answer, and that's okay. So now the other option is to determine the roots by using the quadratic formula. When we use the quadratic formula, it's important that we provide exact answers. So in other words, not a decimal, keep all your root signs. So the first thing we do is we identify our a, b, and our c, and then we just put them into our quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm just going to sub in all my values. Square root of 3 squared minus 4 times negative 4 times 8 all over 2 times negative 4. So that will give me x equals -3 plus or minus the square root of 137 all over -8. And because of this plus or minus, it gives us our two answers. So we have one answer where we have plus root 137, and we have another answer where we have minus root 137. So those would be our two answers. Let's try the next one. So for this one, same idea. We have to label our A, B, and C. But in order to do that, we have to have it in the proper order. So we always have to start with the term that has the highest exponent, and then we go down to our constants, or the ones that don't have variables at the end. So now we can label our A, B, and C and put that into our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And now we just fill in our values. All over 2a. So that will give us -4 plus or minus the square root of 120 all over 4. And because of that plus or minus, this gives us two answers. So x1 is going to be -4 plus root 120 over 4. And x2 is going to give us -4 minus root 120 over 4. And that is our last example.